week 5 of the Concentrator Talk, brought to you by the Oxygen Alliance. So my name is Mwali Lungu, and I'm currently in Lilongwe, Malawi, and I'm pleased to be hosting the Concentrator Talk for today. So joining me are my colleagues Timothy Mtonga and Amapreet Rai. So we'll be here every week at this time, same time, to answer your questions about concentrators and concentrator repairs. So remember that you can always send questions by email to info@oxygenalliance.org, and we'll do our best to respond during the next Concentrator Talk session. So if you have any questions that you would like to ask during the session, you can just type them into the chat, and then we'll do our best to respond to them. So just a reminder to everyone to please keep your videos turned off and your microphones muted unless you are asking a question. So again, with me, we have several technicians with us on the call to answer your questions. We have Paulina Mohosho joining us from Johannesburg, South Africa. We have Kuwinda Singh from Chandigarh, India. Georgie Kwanga and Tedo Sinjani from Lilongwe, Malawi. So last week we introduced Sharon Gozo and Francis Sambani. So these are our two crew chiefs for the Open02 mobile workshop. So this time around, Sharon is going to be part of the technicians responding to your questions. So just like we did last week, we are going to have a topic of general interest, which is how the double wobble compressor works. So we'll get to that after we've gone through a couple of questions. So we have polls also at the end of each question. So please be sure to attend to them when they pop up. For those of you who are not able to see the polls menu, if you go to the bottom right of your screen and expand the activities menu, you should be able to find the options menu from there. Another quick reminder that for all of those who are just joining us and you haven't submitted your contact details yet, please do so in the chat so that we can add you to our mailing list. Just make sure you also let us know which country you are joining from. So as usual, I'm going to read out the questions and ask one of our technicians to respond. So we'll also paste the questions in the chat just in case you didn't hear the questions fully. All right, so moving on to the questions now. Our first question of the day says, I want to buy an oxygen analyzer for checking the purity of oxygen concentrators. So we have at our private hospital. So any recommendations from you guys on which one I should buy? I'll ask Teto to take this one up, please.
Yeah, sure, Maui. So oxygen concentrators are medical devices whose performance needs to be checked at least once a week to make sure they are performing as required. So the key activity when checking the performance of concentrators is to conduct an oxygen purity test. You can only check the purity by using a measuring instrument called an oxygen analyzer. So an oxygen analyzer is made up of different components, and one of them is an oxygen sensor. So there are 9 different types of oxygen sensors, but the ones that are commonly used in oxygen analyzers are the electrochemical oxygen sensor and the ultrasonic oxygen sensor. So the electrochemical oxygen sensor measures a chemical reaction within the sensor that creates an electrical output proportional to the oxygen level. So analyzers with this kind of sensor are cheap, but have a lifespan of only 2 years because the chemical stops reacting over time. On the other hand, the ultrasonic oxygen sensor uses sound speed to measure the amount of oxygen in gas or liquid sample. So analyzers with this sensor do not have like a specific lifespan, but they work forever as long as the electronic components are functioning properly. So furthermore, these analyzers have the ability to measure oxygen flow in addition to oxygen purity. So the analyzers with a ultrasonic oxygen sensor are more costly than the electrochemical analyzers. So with that being said, the type of analyzer you want to purchase depends on how much money is available. But I would recommend, or it's worth it, buying the analyzer that uses the ultrasonic oxygen sensor, as it has a long lifespan and is able to measure flow rate and purity at the same time. It is also important to note that you can easily make your own oxygen analyzer using an Arduino and the ultrasonic sensor. So on the Arduino, you could use any other microcontrollers like the PIC32. If you have even, I guess the Raspberry Pi could work as well, but that would be more costly. So we used the Arduino and the ultrasonic oxygen sensor. And the cost was around $40 in parts. So we have made this analyzer before, as you can see on the power on the graphics there. So this gives you more advantage to replace any part, such as the sensor, if it's broken, because you have control of the whole device. Yeah, that's it. Thank you.
All right, thank you very much, Tato. So I'd like to ask the other technicians if you have any other comments to add on to Tato's explanation. All right, no further comments. Okay, so we will now move on to our first poll of the day, and please respond to it. It's going to pop up anytime now.
The poll has been launched. If we'll give it a few minutes for people to respond.
Thank you, Ampri.
Maui, do you want to just remind everybody, because we only have one answer so far, and we do have a lot of new people on the call. Do you want to just remind everyone how to get to the poll in case they didn't see it pop up?
Yeah, so for those just joining us, if you go to the bottom right of your screen, you should be able to see the activities menu. If you click on that, you get an option which are on the options, pause is one of the listed options. So that's how you can get to there.
All right, so we have no votes for less than $100 and we have 2 votes for above $100. But it looks like there is also nobody who has answered that they don't have an analyzer, which is great. We definitely encourage all technical operations to have an analyzer with them. I will stop the poll now.
All right, thank you, Amapri. So moving on with the questions now. The next question says, I am working on a UL 7F5 oxygen concentrator. When I switch it on, it is able to display the elapsed time and the green and yellow LEDs illuminate, but it suddenly stops running just within a minute and makes continuous sound. What are the possible causes of the problem and how can I solve it? So I will ask Paulina to please take this question up.
Thank you, Moibi, for the question. Okay, so the problem mentioned is mostly associated with jammed hoses, improper electrical connections to the solenoid valves, faulty valves, and failure of the main control board. The hoses are the tubes that connect various components of an oxygen concentrator through which the air passes. If these tubes are blocked, the pressure at the outlet of the tube will drop. This is then sensed by the pressure sensor that sends signals to the control board. Upon the interpretation of the signal, the concentrator is turned off immediately because the purification of air by zeolite depends on pressure. So if pressure is below the normal range, the purity of the oxygen produced is affected. Hence, to avoid producing low purified oxygen, the concentrator will turn off immediately. So here are the things that you would need to do. You would need to check the air hoses connected to the valve. You would need to check if they are jammed or blocked, then open the air passage or replace the hose if necessary. The second thing that you would need to do is you would need to check the pressure sensor if it is not damaged, and also check if it's properly connected to the control board. Replace the sensor if there's any visible damage, or reconnect if there is poor connection that is observed. So to make sure that there is continuous producing of oxygen, an oxygen concentrator uses two canisters, which are sieve beds that alternate at the end of each cycle. When zeolite in one sieve bed is saturated with nitrogen, the air starts to flow on the other canister with fresh zeolite. The direction of air flowing to the canisters is controlled by the directional control valves, which can be the rotary valves or the solenoid valves in other machines. These valves close and open depending on the signal received from the control board that keeps track of what happens to the canisters. If the valves are faulty or blocked, then the flow of air to the sieve beds are affected, thereby affecting oxygen production. So then in that case, you would need to check the valves if they're working properly, and if they are supplying enough external voltage to the valve. You should be able to hear a clicking sound when the valve is working. So if the valve is blocked or fails to open, then replace it. If it is possible to open and reassemble the valve, then you can do so. So if it is the control board that is faulty, the valve may not receive signals or can be receiving wrong signals that can lead to the malfunctioning of the valve, hence affecting the flow of air. The wires from the board are connected to the valve via a connecting plug. So if these connectors are not well secured, the valve cannot operate, leading to blockage of airways. So what you would need to do in this case, if of the control board problem, then you would need to check the plugs if they're connected to the board and connect them if they are not connected. Also make sure that the cables from these connectors are connected to the control board. If all other possible causes are dealt with, but there's no change, then the issue is with the control board. Try to replace the control board with another one if it is available. If the oxygen concentrator reverts to its working condition, then the old board is faulty. Replace the component on the board and replace the ones that are damaged or not working properly. Replace the board if it is available. Thank you, Marty.
Thank you very much, Paulina, for that explanation. I don't know if we have any questions from our audience or comments to add on from the other technicians. Please, you are free to add on to that. All right, so moving on to our third question of the day now. There are many oxygen concentrators of Chinese origin in the field, especially in East African countries. I never find a service manual. Mails to the manufacturer remained unanswered. How should I tackle the problem? I'll ask George to take this one up, please.
Thank you, Maui. Indeed, manuals of such concentrators are scarce to find and sometimes not available at all. As a reminder, all concentrators have the same theory of operation, pressure swing adsorption, regardless of the design. This means that they are all related. Even though you may not have a manual for a specific model, it is possible to learn from other models. Part of the goals for the Oxygen Alliance is putting together a concentrator library for these models of concentrators and creating documentation. We advise you to share a clear front and back picture of every new concentrator that you will come across. Thank you.
Thank you, George, for that explanation. So I think we got this question, we received this in our email. So if you are here and you have any further questions on this, please, you can come in. Otherwise, I would like to ask Amapri to open up our second poll of the day.
The second poll has been launched. We'll give it a minute or two to get some answers. And I'd just like to, while people are answering that question, just add on to what George was sharing. We really do encourage you to join the Auction Alliance. You don't have to have a full company set up or anything that has been operating for a long time. We're here to help you and to grow the library for everyone. So one of the advantages of being an Alliance member is that you are able to share with us any concentrators that you find, and we will build out a complete library where we're talking about how to fix each component. We'll try and help you find the manuals if we can. And of course, we've got Concentrator Talk to answer any of those questions that you have when you get stuck on a part. So it seems like if we're looking at the answers to this poll, that it is quite often that we come across concentrators with no manuals. So there's actually 4 votes for often and only 1 vote for occasionally and 0 for never. So it seems like this is a real problem. So thank you very much to whoever shared this question with us, and we hope we can help you address the challenges that come from not having a service manual. Thanks, Maui.
All right, thanks, Amapri. All right, so moving on to the next question now. I am looking for an oxygen concentrator. Which brand of oxygen concentrator would you recommend? So I'll ask Paulina to please take this one up.
Thank you, Mwabi. So the most brands of oxygen concentrators are good. The most important thing that the oxygen concentrator you would like to buy should have an international approval. For example, it should have a Food and Drug Association or International Organization of Standardization, on also the World Health Organization. So the other thing that we would recommend that you check is also consider the specifications that suit your requirement. So you would need to consider the different brands based on the flow rate, the battery backup, the alarms, especially for the low purity of the oxygen. So you would want to get a machine that will alert you when the machine has a low purity. Also consider the weight, the power consumption, and the portability. So that's what we would recommend for you to get. Thank you.
Thank you, Paulina. So if we have any further questions on that, you can please raise your hand and then we'll attend to it. So moving on to our third poll of the day now. Amapri, can you please launch that one?
I have launched this poll. And we're just trying to understand a little bit more where the members of this call are joining in from. So if you would be so kind as to answer that for us. And also while you're answering, if you have not already shared your email address with us so that we can give you updates, share with you when new videos have been posted to our YouTube channel, remind you about this call, please do share right now. I think we do have some new faces with us today, and welcome to everybody who this is your first Concentrator Talk. We hope you're finding it useful and you will be back. We'll give it just another 30 seconds on that poll.
Yeah.
Okay, it looks like everyone is from Africa. So thank you very much.
Thank you. All right, moving on to our next question now. With continuous use, the inside of an oxygen concentrator accumulates with dust. The dust can also accumulate inside the compressor. I am aware that an oxygen concentrator uses an oil-free air compressor. What is the best way to clean a dusty compressor? Is it okay to use an alcohol-based solution for cleaning? So I'll ask Sharon, our new member of the team, to please take this one up.
Thank you, Maui. Okay, so the air compressor is one of the many parts of an oxygen concentrator. It sucks ambient air. While sucking, dust is also sucked together and can accumulate within the walls of the intake hose and sometimes within the insides of the air compressor. The gross particle filter and the intake filter are used to prevent particles and dust from accumulating inside the airways and affecting the purity of the air. Firstly, you have to make sure that you have a gross particle filter and an intake filter for your concentrator, and that the gross particle filter is cleaned weekly with a soapy water. And the compressor can be easily cleaned by blowing it with air from another air compressor. This will blow away the dust from the surface of the air compressor. Sometimes this alone is not enough to get rid of all the dust from the surface of the compressor. I would prefer using a damp cloth to get rid of the dust instead of an alcohol-based solution, as alcohol can react with fluoride and can reduce the performance of the concentrator over time. Thank you.
Thank you, Sharon. So if we have any follow-up questions on that, you can please raise your hands and then we'll attend to it. All right, so if we have no questions on that, we'll move on to our next question, which says, are oxygen concentrator flowmeters for different concentrator models with the same flow rate interchangeable? So I'll ask Kowinda to take this one up.
Thanks, Bobby. So a flow meter is used in an oxygen concentrator as a component to regulate the flow of oxygen gas going to the patient. Is placed just after the pressure regulator, which is inside the machine. The pressure regulator is a device designed to maintain the outlet oxygen gas pressure to the desirable value. So different flow meters come with different flow rates. Most oxygen concentrator flow rates come in 5 lpm, 9 lpm, 10 lpm, or 15 lpm. So most flow meters designed for a different concentrator model, but with the same flow rate and not interchangeable with each other. So they are not interchangeable with each other because of the difference in the positioning of inlet and the outlet ports, and the difference in the pressure at which they were calibrated. So calibration is the most value. However, flow meters designed for a different concentrator model but with the same flow rate are interchangeable only when indicated to have been calibrated at the same pressure and have the same footprint, having same positioning, same inlet and outlet ports only. So normally they are not interchangeable. If they are calibrated with the same parameters regarding pressure, then they can be interchangeable. Thank you.
Thank you, Kowinda. So if we have any follow-up questions on that, please raise your hands and ask your question. So just a quick reminder to all of us that if you have a question, either related to the questions that we have received, or if you have a new question, you can just paste it in the chat, and then if we have the time, we'll attend to it now. If not, then we'll reserve that question for our next concentrator talk. All right, so moving on to the next question. I am working on a 5 liter per minute DeVilbiss oxygen concentrator. I just refilled the sieve beds with new zeolites, and I wanted to do a pressure test before I do a purity test, just to make sure that the pressure at the outlet is within a recommended pressure. Typically, the bore in the flow meter has to drop down to the base of the flow meter if you close the patient's outlet. But in my scenario, whenever I put a pressure sensor on the patient outlet, the bore in the flow meter does not drop down to the base of the flow meter. And when I switch the concentrator off, the bore drops to the base. What can be the problem and how can I fix it? So I'm going to ask George to please answer that question.
Thank you, Maui. If the flow meter is not working as expected, here are the steps you can take to troubleshoot and find the source for your problem. First, check for leakages in the airways, starting from the patient outlet down to the product tank. To check for these leakages, disconnect the tube from the flow meter outlet that has a bacterial filter and a check valve. Then use your thumb to seal the flow meter outlet, and if the bore inside the flow meter drops, it means the connecting tube, including the bacterial filter and the check valve, has leakages, and the flow meter is not blocking. Replace the tube, the bacterial filter, and the check valve if they are leaking, and reconnect it to the flow meter outlet. This should fix the problem. But if you remove the flow meter outlet tube, you still have the bore floating after closing the outlet, your flow meter might be broken. You have to replace it with a working flow meter with the same flow rate. Thank you.
Thank you, George. So if we have any follow-up question on that explanation, please raise your hand or just unmute, and then you can ask the question. But if we have no further question on that, we are going to take a slight diversion from the question and move on to our topic of general interest for today. So today we'll be talking about how a double wobble compressor works. So Tato, take it away.
All right, thank you, Maui. So I'll now talk about how the double wobble compressor operates to compress the air. So there are 4 categories of air compressors that are available, and these include loaderless screw compressor, reciprocating compressors, axial compressors, and centrifugal compressors. So the double wobble compressor is placed in the category of reciprocating air compressor. So the double wobble compressor is commonly found in oxygen concentrators, and today we are going to talk about how the compressor works. So oxygen concentrators work with air compressor in order to separate nitrogen from oxygen in order to produce this compressed air. An air compressor is used, and depending on the size and its capacity. So the compressor can either be a single piston or a double piston, but the theory of operation is the same for both types. So I'll now talk about the piston movement to start with. So the motion of the piston in a double wobble compressor is slightly different from the ones we find in the car engine. So in the car engine, the piston and the connecting rod are 2 separate components. This means that when the connecting rod moves, the movement of the piston is slightly different, and this ensures that the piston moves up and down. And the setup is different in the double wobble compressor. In this compressor, the connecting rod and the piston are connected, and then when they move, the whole thing moves together. So if Abampi, you can go to the next slide. Okay, I thought I had it there, but never mind. Okay, so the connecting rod and the piston are connected, and when they move, the whole thing moves together. So this is what leads to the locking movement of the piston in the double wobble compressor. So most of the oxygen concentrators are fitted with the double wobble compressor, and the double wobble compressor basically has two pistons that act in opposite direction when sucking and compressing air, which means that one piston is sucking the air and the other piston is compressing the air. And it does vice versa in the next cycle. So this kind of movement makes the compressor very efficient. And the double wobble compressors have one inlet and one exhaust port, and the pistons are connected using pipes. So in order to achieve the compression and the suction, there are a number of small components within the compressor that work together in order to achieve this. So I'm going to start with the piston rod. So the piston rod connects directly to the motor and is responsible for moving the piston up and down, which results in the pumping and the suction process. And then there's the piston. So the piston is connected to the piston rod and is there to hold the cap retainer in place. And the cap retainer sits on top of the piston and is responsible for holding the piston cap in place during up and down movement. So I think if now you can go to the next slide. Next slide. Okay, so that's the cap retainer, and then I'm gonna talk about the cylinder sleeve. So the cylinder sleeve is there to provide a chamber where the suction and compression is to take place. So for oil-free compressors, the cylinder sleeve is coated with a lubricating material which helps to improve the performance of the compressor. And then there's the Oring and the gasket. I think this one is on the previous slide. Sorry, I got the slides in different sequence. Yeah. So there's the gasket there. So the ones that are responsible for providing a tight seal inside the compressor. So this is the Oring and the gasket. The Oring sits between the cylinder sleeve and the valve plate. The head gasket sits between the valve plate and the compressor head. So the head gasket also helps to separate the intake side and the exhaust side of the compressor. And then moving on to the other last part known as the flapper valve. I think it's on the next. So that's the Oring, that's the head gasket. Next, okay, so sorry, the previous one. I saw the ear. Yes, there, thanks. So the flapper valve, or known as the lead valve, is a flat piece of metal that is fastened to the valve plate and is the one that is responsible for channeling air from inlet port to the exhaust port. Yeah, so just talking about theory of operation on the compressor. When the piston moves up and down, the piston cap creates a vacuum inside the cylinder sleeve, and this causes the air from the atmosphere to push down the lead valve on the intake and gets inside the cylinder sleeve from the inlet port and pushes down the lead valve on the intake side of the valve plate. So it gets inside the cylinder sleeve. So when the piston gets to the base, it starts to rise again. And as it rises, the air inside the cylinder gets pushed upwards. The lead valve on the intake port gets pushed upwards and creates a tight seal on the intake port, leaving the air with one way out, which is on the exhaust port. So the lead valve on the exhaust port is on the other side of the valve plate, and it gets pushed upwards, and the air gets squeezed out from the cylinder from there. So this process is for one side of the compressor, but then the movement are mirrored to the other side, as I said earlier. So one side of the compressor is in its suction stroke, and the other side is on its exhaust stroke. So basically, this is how compressed air is generated in a double Wobble compressor. Thank you so much. Back to you, Maui.
All right, thank you very much, Mtedo, for that explanation. If we have any questions or comments on the theory of operation of the double Wobble compressor, please raise your hands, and then we'll give an answer to that. So Amapri, if you can please open up the next poll.
Yes, I have launched the next poll. We just like to understand if this topic was too detailed enough, or you're looking for more detail. So if you could please answer that poll, we'll give it a minute. Okay, it seems like we have all of the votes for detailed enough. So thank you, Mtedo. Your explanation was excellent. Back to you, Molly.
Right. Thank you, Amapri. So moving on to our next question now. So the next question says, I have a DeVilbiss 525 concentrator. When I switch it on, it runs for a few seconds, and then the compressor relief valve pops. It stops after a few seconds and then pops again. What might be the problem? Kuwinda, can you please take this one up?
Thanks, Moabi. So an oxygen concentrator takes in air from the atmosphere and filters out nitrogen and produces oxygen. So the compressor compresses air which goes to the seabeds. The air goes into the seabeds where nitrogen is trapped. So for that process, a rotary valve is in this DeVilbiss 525 concentrator. There is a rotary valve. See, some machines we have solenoid valves, some have pneumatic valves, some have four-way valves. So differ upon the other models. So in this there is a rotary valve. So allows the feeding and purging of beds simultaneously. The relief valve opens when there is pressure build up in the compressor. There is no other passage to release the pressure. This happens when there is a blockage in the beds. So to check the seabeds, we have to remove the cover of the concentrator, then switch it on. Start with disconnecting one seabed outlet and listen alternately if the compressor relief valve will pop up again. If it does, reconnect the bed and disconnect the other bed. Listen carefully if you can hear the relief again. The relief valve stops. Then the bed you have disconnected is the one blocking the air. So for that, we have to remove the old zeolite from the beds and have to change the zeolite of both the seabeds at the same time. So that is for the seabeds. This fault can be due to faulty rotary valve also, due to seabeds, choked seabeds, due to faulty circuit board also, because that is not giving supply to the rotary valve, then it will happen. Other can be the exhaust muffler can be choked. That can also cause this problem. So these are some of the reasons for popping up of the compressor. Thank you.
Thank you very much, Kuwinda. If we have any comments or questions on that, please, the floor is open. All right, so moving on to our next question. I have a DeVilbiss 515 concentrator that I have pulled out of the ward because it was malfunctioning. The concentrator was in the children's ward and it was continuously being used. The concentrator has been performing perfectly all this time, but now, whenever the concentrator runs continuously for 20 minutes, the unit begins to overheat. And then it shuts down after some time. I have opened the unit up to see what's going on inside, and I discovered that the fan was jamming when rotating. How can I solve this problem? So Sharon, can you please take this one up?
Thank you, Mari. So the first thing to note is that every concentrator has a thermostat inside to keep track of the temperature of the unit. When the temperature of the concentrator exceeds the setting of the thermostat, the device will shut down until the temperature goes down again. In order to keep the temperature down, the concentrator has a fan mounted at the bottom of the unit, and the fan works in that it pulls the hot air from the inside of the unit and pushes it out of the unit. When the fan is not running or when the air passage gets blocked, the hot air will remain inside and increase the temperature of the unit. So, in order to fix the problem with your fan, you need to find out what is causing it to jam. One thing you should do is to try and rotate the fan and feel how smooth the blade is rotating. One thing we have discovered is that the soundproofing material that is placed inside the device in order to reduce the noise that the machine produces becomes loose and falls off from the panels. The soundproofing material breaks up and pieces of the material can get to the fan housing, causing the fan not to run smoothly and jam when the fan blade hits these sticky materials. We think this could be the cause of your problem, and in order to fix this, you have to remove the fan and clean it up so that the fan blade rotates smoothly. Then you can press it back again. Thank you.
Thank you very much, Sharon. So if we have any questions on the explanation that Sharon just gave, please you can raise your hand or just paste a follow-up question in the chat and then we'll attend to it. All right, moving on to our next question. When a gross particle filter has worn out or has been misplaced, is it proper to use the concentrator without a gross particle filter? So I'll ask Kuwinda to take this one up.
Thanks, Modi. So oxygen concentrators come with cabinet filters, also known as gross filters, so which prevent large dust particles from entering into the concentrator. These small dust particles that make their way through the gross filter are trapped by the intake filter, so ensuring that you have required oxygen, and thereby ensuring the proper oxygen purity level. Hence, running the oxygen concentrator without gross particle filter results in particles entering into the concentrator, which in turn may cause blockages and reduced oxygen purity. To keep the concentrator running properly and producing the required oxygen purity level, the gross filter needs to be cleaned with water on regularly basis, and there is a need to keep the concentrator running while the filter is being there is need to keep the concentrator off while the filter is being cleaned. A spare filter, if available, can be used. It is recommended that the gross filter must be cleaned weekly and should be replaced when it is damaged. So for the long life of a concentrator. Thank you.
Thank you, Kuwinda. If we have any follow-up questions on that, you can please ask. If we don't have any further question on that, we'll move on to our final question of the day.
Sorry, Maui,
Please.
if I can
Yes.
add something to that.
Yes, please.
So actually, just because I think the DeVilbiss concentrators are fairly common and popular across a lot of our markets, I just want to add that the gross particle filter in the 525 units was actually found not to be necessary in late 2020. So the newer models of the DeVilbiss 525 concentrators actually come without that gross particle filter. And the reason for that is, as Kulwinder was saying, there's a couple other filters that do work in the device to remove dust or particles that come in. And as per their testing, they found that their intake and other filters were quite robust, and they did not need that gross particle filter to also be included. We actually get questions on that all the time. It is not a mistake or a fault. The filter's purpose is to remove any dust or particulates that are coming in from the air to keep the machine running. But there's other ways to make sure that the critical components inside of a device are working the way they should. So particularly in that DeVilbiss 525 unit, that gross particle filter is no longer included. If we come across other manufacturers that make a similar design change, we will, of course, update you. And if you find any concentrators that come without that gross particle filter, please do update us so that we can share that information with everyone else, so that everyone knows what's new and changing with the available concentrators. Thank you.
Thank you, Amapri. So just a follow-up question from me. So you said that was proved for all the models that are being made after 2020. Does that apply for the older models, or it's just for the newer models that are coming in?
It's a great question, Maui. I think the older units can be used without that filter as well. The whole point really was that they did some engineering analysis, and they found that what was being prevented by that gross particle filter wasn't significant compared to the other filtering that was done. Another change, particularly to the DeVilbiss unit, is they actually added some internal filters with that same design update in 2020 towards the end of the year. So let me maybe correct myself to say the versions after 2020 that come without that filter should be the only ones that are used without that, because there was an internal additional filter that was added around the compressor. And the older units prior to 2020 don't have that compressor around, that filter around the compressor to make sure there's extra protection there to balance out from the cabinet filter. But of course, the cabinet filter, it is something that the provider needs to change, or the patient, depending on whether it's in a hospital or in a patient's home. So the decision was kind of taken that there's something that we could do internal to the device that prevents the problem, and you don't need to rely then on a patient or a nurse or somebody to wash that filter every week or every couple days in dustier environments. I hope that answers your question.
Yes, all right, thank you. Okay, so I don't know if we have any further questions on that. If not, we'll move on to our final question of the day, which says, in some cases, when the gross particle filter has been worn out, people tend to use a mattress foam or a sofa foam as a replacement for the original gross particle filter. Is it right to use the foam mattress as a replacement for the original particle filter? George, can you please take this one up?
Thank you, Maui. The material used to make mattress foam or sofa foam is very much different from the one used to make regular concentrator gross particle filters. In addition to that, the mattress foam or the sofa foam is very compacted compared to the original gross particle filters. As such, they can easily be clogged by dust or any other debris, hence reducing the amount of air being sucked by the compressor from the surrounding, which in turn reduce the oxygen purity levels and the oxygen concentrator produce. Therefore, it is in this situation where one has no spare gross particle filter to use, as a replacement for the worn-out filter, I would recommend that they use a gauze bandage instead of using a mattress or sofa foam. This is because the gauze is loose than the foam, thus it can reduce the ocean impurity levels. Thank you.
All right, thank you very much. So if we have any questions or comments on that, please raise a hand and then we can address it. If we have no further comments, Amapri, can you please open up our last poll of the day?
Yes, I have launched this poll, and the question is, how available are the gross particle filters in your country? So if you can just let us know if you find it easy to get these, if they're difficult, if you have any other comments. We know, as we've discussed over the last couple of questions, that those are very important to the function of a machine. So whatever we can do to maybe assist in getting those gross particle filters for you through the Alliance, we would be happy to do that. And it seems like most of the answers are in and they are difficult to find or not available at all. All right, thanks, Molly.
Thank you very much, Amapri. So this brings us to the end of our session today, and I would like to thank you all for joining us this week on our Concentrator Talk. Remember that we'll be here again next week, same time, and if you have any questions, you can send them to us in advance at info@oxygenalliance.org, and we'll do our best to answer them. Be sure to visit our website, Amapri, maybe if you can paste that in the chat, to learn more about the Oxygen Alliance. So we also have a YouTube channel where all the recorded videos of the previous Concentrator talks are posted. So if you missed our previous talks, you can just go on our YouTube channel and you'll be able to find all the recordings there. So please don't forget to subscribe to the channel when you get there. And yeah, for those of you that haven't sent us your emails yet, please do so in the chat, and then we can add you to our mailing list. So that's all from me today. I don't know, Amapri, if you have anything to add on.
Just a welcome and thank you to the new people who've joined us today. We hope you found it useful. We will keep the chat open for a few minutes in case you want to take those links. And please do, as Maui just asked, please do share your emails with us. We have a lot of information that we'd like to share with you, and that is the easiest way for us to do it. And do let us know if you have any questions. Otherwise, we will be here again next week, same time. And thank you.
Thank you. Have a great week, everyone. We'll see you again next week.
Thank you. Bye.
Thanks, everyone.
Thanks.